to combine economic and social progress in developing countries with caps on greenhouse gas emissions, to make energy available at market-compatible prices, to substitute a significant amount of fossil fuel use with renewable energy sources. These are just a few of the challenges to face after the Copenhagen Climate Summit 2009, where 191 countries gathered to discuss about the issue of our planet's global warming. These challenges that concern the future of all humanity can only be overcome through strong political commitment on the part of the major producers of CO2, above all China, the United States, the European Union, Russia, India and Brazil. But politics is not the only key player. A crucial role is to be played by research, in order to improve the technologies with which energy is produced and to make this mission a practical possibility. As one of the most promising technologies, fuel cells can contribute to the achievement of these goals. Fuel cells are electrochemical devices that convert the energy contained in a fuel directly into electricity and heat, bypassing combustion. This electrochemical conversion allows for controlled exploitation of the heating value in the fuel with minimal loss and without the emission of combustion products harmful to the environment. Thanks to this feature, fuel cells also achieve very high efficiencies, which can surpass 50% electrical even at small scales, and can thereby contribute to a considerable saving on primary energy sources. The final hurdles to overcome in order to get fuel cells firmly on the market involve increasing their service life, cutting component manufacturing costs, and utilizing fuels that are not pure hydrogen. At ENEA, the Italian Agency for New Technologies, Energy and Sustainable Economic Development, research is carried out in the field of fuel cells since the beginning of the 80s, in collaboration with industry, academia and other research institutions. Polymer electrolyte membrane or PEM fuel cells are capable of producing very high power densities at considerable efficiency and operate at low temperatures, below 100 degrees Celsius. This makes them particularly suitable for vehicle traction and portable applications. At the ENEA laboratories, new materials and components are developed for the improvement of performance and for increased competitiveness of PEM fuel cells. By using nanotechnologies, the platinum load on the electrocatalysts can be significantly reduced. Platinum nanoparticles are electrodeposited on carbon nanostructures created by chemical vapor or electrospark deposition, at loads of less than 6 micrograms per square centimeter, keeping performances unaltered. In collaboration with industry, stacks and small-scale systems fed by GPL and natural gas are also tested and characterized, as well as those fed by hydrogen. High-temperature fuel cells, like the molten carbonate and solid oxide fuel cells, produce electricity at higher efficiencies but lower current densities than PEM fuel cells, and are therefore more suitable for stationary, combined heat and power production. Research work on high-temperature fuel cells also involves lowering material and fabrication costs, and at FN, an ENEA-affiliated company, a process has been developed for plastic, water-based extrusion of the material for ceramic and metal components for molten carbonate fuel cells. With respect to the conventional process of tape casting, extrusion greatly improves the yield and manipulability of the produced tapes, as well as eliminating the use of toxic solvents. One of the major opportunities for high-temperature fuel cells is feeding them with alternative fuels from renewable sources. This highly promising application is researched at ENEA and is aimed at the optimization of the so-called waste-to-energy chain. Waste often still contains significant amounts of energy that can be recovered and exploited to the full using fuel cells. According to the type of waste, there are different ways of concentrating their residual energy and producing alternative fuels. Heterogeneous waste and woody biomass are ideally converted by gasification, where the primary material is thermally decomposed in oxygen-lean or oxygen-free atmosphere. In this way, a fuel gas is produced rich in hydrogen and carbon monoxide, a process studied at the ENEA Research Center of Trisaia, where different gasifier types are under investigation of several sizes and technologies fed with biomass and refuse-derived fuel. For organic waste such as sewage sludge, manure, or refuse from the agriculture and food industries, a simple tried and tested technology is anaerobic digestion, which is an ancient technique to neutralize biologically active organic streams, like for example pig and cow slurries, as still happens in this Envitec plant opened recently in Mantova. In anaerobic digestion, colonies of bacteria decompose the organic matter, releasing hydrogen, methane and carbon dioxide. These are ideal components for energy conversion, and this application is indeed enjoying rapid growth across Europe. In ENEA laboratories, the conditions of fermentation are optimized for maximum production of methane and hydrogen, with minimum yield of undesirable impurities, such as sulfide compounds, which are particularly hazardous. Before such waste-derived fuels can be utilized in a fuel cell, the gas has to be conditioned, which means purified of contaminants that are harmful to the cell, and reformed, a relatively common process that makes the fuel fit for electrochemical conversion. Both these steps are tested at ENEA, as they are made particularly complex by the highly variable compositions of alternative fuels, due to the nature of their origin. Therefore, ENEA is also seeking to improve the robustness of high-temperature fuel cells by adding specific ceramic materials to the components and subsequent testing in single-cell setups. The experimental activities and research expertise are then transferred from ENEA to industry as mutually beneficial collaboration. The interest of industry is particularly focused on decentralized generation appliances, ranging from single kilowatt scale cogeneration for residential environments to supplying combined heat and power, or CHP, to players in the industrial and tertiary sectors. These applications allow for the fullest possible exploitation of the utilized fuels, which are converted on the spot at high efficiencies, even at modest scales. Ansaldo Fuel Cells is the biggest Italian industry in the field of fuel cells. At the factory in Terni, components, modules, stacks and systems are assembled based on molten carbonate fuel cell technology. Their latest generation 100 kilowatt stack is due to be coupled to ENEA's circulating dual fluidized bed gasifier for testing of its performance on gas from biomass feedstock. Other Italian industries cooperate with ENEA towards the development of micro-CHP systems. Together with ICI Caldaie and Exergy fuel cells, a 30 kilowatt system based on PEM fuel cell technology will be developed and tested. Ariston and SOFC Power, among the world leaders in solid oxide fuel cell technology, are partners in the development of a 3 kilowatt system for single households. Both these systems will operate on grid-quality natural gas and aim to be ready for the mass market of domestic appliances within the next 3 years. Fuel cells have long been a promising prospect, but thanks to continued commitment from research and industry, this promise is now being materialized in finished products, tried and tested, of high quality and with strong potential to help build an energy infrastructure based on efficiency, sustainability and personal responsibility.